we're going to move on to looking at defining a set of parametric equations that will give us a circle on the xy axis. And a lot of this is going to be pretty similar, right? So right here, what we're going to do first is we are going to say, a circle is defined on the xy axis with a center. Right here, our center for our circle is the ordered pair 5, 6, and of course the radius. And we can sort of look to see our radius here as being a length of 3. So we can say our radius is 3, r equals 3 plus, right? Now, just like before, what I'm going to do first is choose an arbitrary ordered pair from the perimeter of my circle, just like we chose an arbitrary ordered pair from our line, right? And we're going to extend a vector with standard representation to that arbitrary point. And of course, that vector extended to the arbitrary point is going to have a horizontal component that is the x value at the head and a vertical component that is the y value. So our vector is going to be x, y. Now right here, what we're going to do next is extend a vector with standard representation from the origin to the center of our circle. And right here, we're going to have that vector as 5, 6, since it's extending to the ordered pair at the center, 5, 6, right? And now right here, what we're going to say is that with a standard position rotation, where we're sort of saying that this horizontal line is representing the x-axis, we're going to be able to have some rotation t that will take us to the direction of that ordered pair on the perimeter of our circle. So there's some rotation t, right, from the positive horizontal that will basically take us in the direction of our ordered pair at the point on the perimeter of the circle. And we can get the unit vector that extends in that direction by saying the horizontal component is going to be cosine t, and the vertical component is going to be sine t. Now this unit vector has a magnitude of 1, right? And we can extend it to that point on the perimeter of the circle by multiplying by the scalar equal to the radius, right? So now right here we've got that vector extending from the center of our circle to that point on the perimeter that our vector xy extends to, right? That arbitrary point that really could be any point. That's what arbitrary means. And so right here what we can basically say is the sum of the vector to the center of the circle and the vector that takes us from the center of the circle to the head of our vector extending to our arbitrary point are going to sum to that vector extending to that arbitrary point. So right here we've got a vector extending to the center, 5, 6, plus our scalar r times our unit vector extending in the direction of that point on the perimeter of the circle, equal to our vector extending to the arbitrary point xy. Now once again, I've not given myself enough room, so I'm going to have to take all this stuff and move it down. And right here, we'll do our math down here so that we don't get cramped up. Now again, we're going to simplify that left side of our equation. So we multiply the scalar 3 through to our horizontal component and our vertical component, and we get our vector 5, 6 plus 3 cosine t, 3 sine t, equal to our vector xy. And then right here we can add our two vectors, adding horizontal components. We get 5 plus 3 cosine t as the horizontal component equal to the horizontal component that is the arbitrary x value for an ordered pair. And we get the vertical component of 6 plus 3 sine t as equal to the vertical component y that represents the corresponding y value to that arbitrary x value. And then right here, we've got our set of parametric equations as x equals 5 plus 3 cosine t, y equals 6 plus 3 sine t, right? And there's our set of parametric equations that will define our circle on the xy axis. So right here, what I want you guys to do is to give this a shot yourself. Right here, we don't need to do as much to make sure that we are defining the same set of parametric equations. I mean, we could basically sort of help ourselves a little bit in sort of saying that, you know, we're going to choose the same arbitrary point, right, xy, right, that we're going to extend that vector to from the origin, right, with standard representation giving us the vector xy, right? But after that, all the steps are pretty much the same. So right here, why don't you guys pause the video, and we will give this one a shot together in a second. All right, guys, so looking at this, we extend our vector in standard representation to the center of the circle, 6, 2. Then there exists some rotation t that will allow us to extend a unit vector in the direction of that ordered pair on the perimeter of the circle that we've extended our vector to, an arbitrary ordered pair, such that we have the unit vector extending in that direction as cosine t sine t, right? If we multiply that unit vector by a scalar of 3, the length of the radius, our vector then extends out to the perimeter of the circle, and we've got the sum of our vectors to the center of the circle, and vector to the perimeter of the circle, a point on the perimeter of the circle, equal to our vector xy extending to that arbitrary point. And we can set up our equation over here. So vector to the center, scalar times vector from the center to the perimeter, equaling that vector extending to that point on the perimeter. And then right here, we're just consolidating that left side. So right here, we would multiply that scalar of 3 through to our horizontal component and our vertical component. And then we would add horizontal components and add vertical components to get the horizontal component of 6 plus 3 cosine, that's equal to the horizontal component of that arbitrary x, and the vertical component of 2 plus 3 sine t, that's equal to that corresponding vertical component that is the arbitrary y. And there's the set of parametric equations. So again, when you're given this in the book or on the test, you're really just given the center of the circle and the radius. And you can go from these pieces of information to the setup of your vector equation that's going to give you parametric equations. Right here, you would basically say, okay, the x and y values of my center are going to represent the horizontal and vertical component of my vector to the center, and then I've got my radius 3 times a unit vector extending in the direction t, which is to that arbitrary point on the perimeter, and then you just simplify in the same ways every time, and it gets you this set of parametric equations. Now there aren't going to be multiple possibilities for these parametric equations. You're always going to come up with the same set of parametric equations for a circle. Whereas for a line, you could come up with a lot of different parametric equations if you were just looking at the line. If you're just given 2 ordered pairs, there's only 2 possibilities. But we'll talk about this more in class. We'll look at it. We'll start reviewing for the quiz, and I'll see you guys in class.